Okay, for the 5.4 quick check, the first question here is talking about oxidation and reduction. And the idea is, what are the clues that help you figure out whether something is being oxidized or reduced? Okay, so oxidized, I always remember oxidized is something like, copper, changing from neutral to copper 2+. Okay, and it gives off some electrons. Okay, so element is oxidized when it loses electrons and its charge becomes more positive. So that's a big thing. And reduction, the same thing, or opposite thing, okay, is that it's going to gain some electrons and it becomes more negative. So an example might be when something like Fe3+ picks up an electron and becomes Fe2+. Or if like Fe3+ picked up 3 electrons and became Fe neutral, okay, that would be possible. Or if we have something like oxygen, okay, turning into O2-, okay, each of those would be reduction. And the other part about that, remember we have Leo the lion says Gur, so losing electrons is oxidations and gaining electrons is reduction. So we have all these clues to tell whether something is oxidized or reduced. Okay, next part here for redox reactions. Here we have copper plus oxygen turns into copper oxide. And one of the big clues there is you have to go through and figure out what are the charges. So anything that's a neutral element has a charge of 0. Neutral element has a charge of 0. Now the compound, these are not 0, they're just balanced. We'll do the -1 first. We know oxygen is -2. Okay, and since there's 1 copper for that oxygen, it must be +2. Okay, so those are the charges. So who's getting oxidized? Whose number is getting higher? And that is the copper. So the copper is oxidized as it goes from 0 to 2+. And the who's getting reduced? Okay, and that is oxygen. Okay, which is going from 0 to 2-. Okay, so 0 to 2- like we did up there. Okay, same thing, next one down. Here we have chlorine, that's a 0. Here's bromine, that's a 0. Okay, the compound, this is 1+ and 1-. And this KCl is 1+ and 1-. So who is changing? Well, the chlorine here, that's changing. And the bromine, that's changing. The potassium is not changing. That's a 1+, not an H. Okay, so who is changing here? So we can say the element, see, Cl0 to 1-, that's being reduced. So Cl2 is reduced as it goes from 0 to -1. The bromide is going from -1 to 0, that's oxidized. Okay, single replacement reaction. So for each reaction, write the products that are formed and the half reactions. Okay, so magnesium and nickel chloride. So we were saying what's going on is we have an element and a compound that's going to turn into another compound, another element. And the compound is going to be magnesium chloride. So that's magnesium 2+, chlorine -. That's MgCl2. And the element we're going to get is nickel. And you can write those either direction. And that's going to be a solid, and that's going to be aqueous. The half reaction, who's getting oxidized? Magnesium is going from neutral to magnesium 2+, and that gives off 2 electrons. And the reduction half reaction will be the nickel. It's going from nickel 2+, okay, picking up 2 electrons and becoming nickel metal. So that's the reduction half reaction. Okay, last one over here for aluminum. Okay, here's an element and compound turning into an element and a compound. Well, the compound is going to be aluminum chloride, AlCl3, and the element is going to be hydrogen, but we have to remember that hydrogen is diatomic, H2. So we need a 2 in front of there to balance. No, that's not even going to do it. Okay, we have 3 chlorines here, so we need to have 3 on the H's, but if I get 3 H's, I'll have 2 H's. So let's go for 6. So if I had 2 aluminum chlorides, that would give me 6 HCl's and 2 aluminums, and I would end up with 3 H2's. So that's how that reacts. The other one above was already balanced. Okay, oxidation. Whose number is going up? Aluminum is changing to aluminum 3+ in a compound, plus 3 electrons. Who's coming down is hydrogen, which is H+, turning into neutral hydrogen, which is H2. So I'm going to have 2 of my H+s and add 2 electrons over here. And that is the whole quick check.